Welcome back to another session of AVR120. Today we are going to be going over how to apply a force to an object with a character controller. So as we kind of mentioned in a prior video, the character controller bypasses Unity's physics engine so that it doesn't interact as a physics object itself. So this is nice in the sense that it avoids some coding that we have to do with regards to generating movement forces and applying physics to a rigid body. But it is not as useful when we want to, apply physics to objects in the world space. It makes it a little bit harder, so we actually have to code around that. So today, we will be coding around that and setting up a way for us to be able to push an object with the character controller. So if we take a look here at the Unity documentation, we are going to be using this on controller collider hit method. Um, so this is on the going to be called from our character here. And essentially what this does is it takes a collider, okay, um, from an object, and if our character intersects with that collider, we will do something with it. In particular, we are going to apply a force to it. So this is often how you are able to um, interact with multiple things in a game. On controller collider hit is one option, but if we're using we're using another collider, we could set something up like on using on trigger enter, which is a method that does a similar thing where if your collider intersects with another collider or an object in the environment, it does something. So it in general is something that we'll be using again, and colliders intersecting with each other is one of the main ways in 3D space to um, have events happen, do things, and so on and so forth. So we'll go ahead and the first thing we'll do here is add a box to the desert environment. So go ahead and click the desert environment and then the prefabs folder, and then we'll go to props. And inside of the props folder, we'll see a crate. And now I'm going to click this crate here, and I will drag the wooden crate into the scene. Okay, so these prefabs, they come with a box collider already. The crate does specifically, and a rigid body. So it already has physics applied to it. Um, Similarly, if you like click on the building here, this has not a box collider, okay, but this has a mesh collider. So a mesh collider is going to conform to the surface of the object. Generally, it's used for objects that are more complicated than a typical, more polygonal-esque object. So this, has a mesh collider as well. This rocks has a box collider though, right? Because a rock is a lot simpler, and the box collider will work just fine for that type of object. Okay. So we'll go ahead and kind of getting off topic a little bit, but we'll click on the wooden crate here. Okay, we'll see that it has all these components, the box collider, the rigid body, so it should have physics applied to it. Okay, so if we go ahead and I'm just going to drag my game back in here, game view, and I'm going to play this. If I walk up to the box, it doesn't move at all. Okay. Um, so we're seeing here that the character controller is not applying any sort of physics to this box. So let's go ahead and set that up. So the first thing we're going to do is we're going to click the wooden crate and we're going to press R. And we're going to scale it up a little bit so it's a little bit bigger. Okay, so we'll go ahead and scale it up from the middle there. That looks pretty good. And we will leave it at that. Okay, so we'll go ahead and we're going to create an script on the player, and we will call this script obstacle move. So double click the obstacle move script, and we will be inside of the script here. I'm just going to move my my game back here. And we'll go ahead and start writing some code. So the first thing we're going to go ahead and do is we're going to call that function I had described before. So we're going to say private void and on controller collider hit. Okay, so it says on controller collider hit is called when the controller hits a collider while performing a move. So that's the character controller, right? It's collider, uh, and when the move function is being called, which is what we are using in our player movement script. So we'll go ahead and add this on, and this controller collider hit variable, okay, is essentially controller. Well, we can read this. Controller collider is used by the character controller dot on controller collider hit to give detailed information about the collision and how to deal with it. Okay, so basically, when a collision occurs with these colliders, right, it will generate. Uh, we'll use this basically hit variable here to get that information that the collision has occurred, and then we will go ahead and do something with it. So the first thing we're going to want to do is get the rigid body component um, of the object that we're colliding with. So we're going to say rigid body and call this rigid body here, and we're going to set that equal to the hit variable dot its collider, so whatever we're hitting, that the collider of what we're hitting, and then the attached rigid body. So we're using this hit variable to detect the hit. We're going to get the collider of whatever we're hitting with, and then we're going to get that rigid body component, okay? So if we go back to the editor really quick here, what we're getting, okay, is for this wooden crate, and I'm actually going to go ahead and drag this under objects here. So this wooden crate, if we double click on the wooden crate here, when the player hits the wooden crate, it's going to hit its collider, okay? And when it does that, it's going to get the attached rigid body component on this wooden crate here, okay? So let's go back to the code here. So now we're going to run a check and say if the rigid body is not equal to null, so if there is a rigid body on the object, okay, then we're going to create a vector3 called force direction, okay, and we're going to apply a force to push it away from the character. Okay, so this is what this is a force to push it away from the direction. It's a direction of the force um, we're going to apply to push away from the character. So to determine the desired direction of that force, we need to minus the position of the character from the position of the obstacle. Okay, so we're going to go ahead and use the hit variable again. We're going to say hit dot game object, okay, dot transform dot position. Okay, so that is the position, okay, of the crate or whatever object, all right, that we are intersecting with that has a rigid body, okay, and a collider. And we're going to subtract our position, okay, from that, from the position of the object, okay? So what this is going to do is push it away from our position. Okay? So we want to go ahead and we want to take that direction, that force direction, and we want to just have this occur on the x plane and not the y plane. So we need to go ahead and freeze it essentially on the y. So we're just going to set the y vector to 0, okay? And then we want to go ahead and uh, normalize the direction of the vector so that it just has a magnitude of 1, so we aren't applying a huge amount of force to the object and just like launching it. So we, not normalize, excuse me, we're going to call the normalize function, okay, which is a built-in Unity function that will normalize the vector 3 and essentially keep the direction, set the vector so it only has a magnitude of 1. Okay, so then once we have this here, we can go ahead and we need to create a float to store the magnitude of the force. Okay, so we can use, uh, we'll go public float, and we'll call this force magnitude. And what we're going to go ahead and do now is we're going to take that rigid body that we got of the object that we've intersected with. We're going to add a force at its position, okay? And we're going to, uh, excuse me, we're going to look at this real quick here. So the add force at position, it takes a vector 3 force, okay? So the actual force of the force that we're applying to it. It takes a vector 3 position, so it takes the position that we are that essentially the character is, okay, and then it's going to just use this force mode class, which applies a physics force. It has different ways to do that. So we're going to take the force direction, okay, the force direction, okay, um, and we're going to multiply that by the force magnitude, okay. Um, so we're going to multiply that by the magnitude, and then we're going to go ahead and um, we're going to pass in the character's position, okay. All right. So essentially, we have a direction that the force is going. We're multiplying it by a magnitude. The force is coming from the player's position, all right, because this script is on the player out game object, okay. And we are going to use the force mode dot impulse, okay, which adds an instant force impulse to the rigid body using its mass. So it's immediately going to apply the force in the direction that we want from the player immediately. Okay? And we can use this force magnitude to basically apply more or less force to the object. Okay? So we'll go ahead and go back into the script here. And we can save it. And then we will go ahead and press play. And we can see here, oh, it's not working. So probably forgot to do. Oh, so I didn't set the force magnitude here, so we'll set this to like 1. And we can go ahead and see that I'm applying a force now to the object when I move into it. Okay? And if I want to say like really launch it, I could set that to 10. When I walk into it, I just literally launch it. Okay? So you'll notice here too, um, works for the barrel, right? But if I walk into the rock, does not work, right? And that is because there's no rigid body on the rock. If I were to go ahead and add a rigid body, it works on the rock as well, right? I'm just going to remove that because it's a rock, so probably shouldn't be that easy to apply force to it and move it. Okay, so that will do it for the obstacle move. Okay, and that is essentially how we're going to get around not being able to apply physics to environmental objects. So the last thing I wanted to go over today is going to be the a sprint function. So we can actually create a sprint function for the player to uh, kind of run depending on if, let's say, they hold the shift key down. So we'll go ahead and do that now. Let's go to the first person player movement script here. We will open that up and we can go ahead and start working on that now. So I'm going to create a public float and I will call this walk speed and I'll set that equal to 10 and then I'll have a public float and I will call this sprint speed and I'll set that equal to 15 and I will have another public float and call this acceleration and we will set that to 10. So what we're going to be doing now is we'll I forgot. We need to add one more thing. So I've showed you how to get input using the input class, but you can actually also go ahead and use another class, okay? And this is key code. And so key code, it says key code returns by event.keycode. This maps directly to a physical key on the keyboard. So basically we can use this to define a sprint key like so, and we can set that equal to keycode dot left shift is what I'm going to call it. So the left shift key. So that actually has a key code already set up. Perfect. Okay, so now what we're going to go ahead and do is we're going to create a new method. And we're going to call this an update. So we'll go ahead and create a new method at the bottom. It needs to be underneath update, but inside of the player movement class. Okay, and we will call this. It will return nothing. So void, and we'll call the method control speed. And what we can do here is we can call this from update. So at the bottom here, I can call control speed. And actually, I don't want it at the bottom. I want it at the top, and the reason being is that I want it to be one of the first things that's checked, so that if it is pressed down, it gets applied immediately. As you know, because code goes in order, right? So you want to make sure that if you're checking things, maybe you want to check things that have like immediate pertinence at the top of the update. Okay, so we'll go ahead and I also want to rename. So I'm going to rename this speed variable. Instead of just speed, I'm going to rename it to move speed. Um, and this will throw some errors because we're using it down here. So we just need to replace this mood speed in the controller.move function. Okay, so just make sure that you are replacing it. This is on line 58 for me. Um, but make sure you replace that speed with move speed or you're going to get an error. And then what we'll go ahead and do is we essentially want to run a check and say if they are holding the key down, okay, so input.getKey down, okay, or excuse me, get key. So get key returns true when the user holds the key identified by the key code enum parameter. You don't have to worry about the enum parameter thing, but basically this is if the key is held down, as opposed to get button down, okay, is called when it's pressed once as opposed to held down. So we will use get key, all right, and we will pass it the sprint key variable we just created, okay? And remember, that's assigned to left shift. And then we want to check and make sure that they are grounded. So we want to make sure that that bool is true. So if they are sprint, so they can't like sprint mid jump, right? And so we're going to set the move speed equal to, and we're going to do what's called lerp, okay? So mathf dot lerp, okay? And a lerp linearly interpolates between A and B by T. So basically, it's going to um, change, it's going to move from one value to another by that T float, okay, right, which is essentially the rate, okay? So it's going to move between Um, essentially, in this case, we want the move speed, okay? If they're holding the sprint key down, we want the move speed um, and sprint speed. So we're going to pass it. It's going to go from move speed to the sprint speed value, okay? And we want it to happen over time. So we're going to give it the acceleration, okay? So it's going to do that over the acceleration, or use the acceleration to basically increase the speed from what your current move speed is to sprint speed, okay? And then we're going to pass that time dot delta time, okay? So we're going to basically just check that, um, multiply that by the time of the last frame, so it's frame rate independent, and we'll go from there. So otherwise, okay. So otherwise, if those conditions are not true, okay, we are going to set move speed equal to, and we're going to do the same thing. We're going to lerp, okay. So linearly interpolate basically just means move from one point to moved from one value to another over time. So we're going to go again, move speed. So our current move speed, so the move speed variable is going to hold our current move speed, okay? And we're going to move from move speed to walk speed, okay? And so walk speed will be like the base walking speed, right? And then we'll do the exact same thing, and we'll use it will linearly interpolate over time, um, using the acceleration as the kind of rate of time, and then we're going to multiply that by time dot delta time. We can go ahead and save this now. And so, again, what we're doing here is if they're holding the key down and they are grounded, we are changing our move speed, which holds our current speed, essentially, and we are lerping or moving between from the move speed number to the sprint speed number, okay? So from 10 to 15, okay? I believe it was 10. From 12 to 15, so maybe we can increase this. I'm gonna put this to like 17. So move it from 12 to 17, okay? And we'll do that over 10, 10f, which is like kind of like milliseconds, and then multiply that by the last time update was called. And then if they're not holding that down, we will set the move speed back down to walk speed. And our walk speed is going to be 10, okay? So that's the original um, walking speed, and we will do that over time there. So go ahead and save this, and now we will run, we'll go back to the editor here, and we can see that we can adjust the walk speed, sprint speed, and acceleration, right? So, and we can see that our move speed is 12. So we'll go ahead and run this, and we'll see that, we're walking at a normal pace. And then if I hold shift down, I start running. I sprint. Okay? And we can see that when I'm sprinting, I launch that thing. So it is applying physics there. Okay, so we'll go ahead and press play. We can save that. That will do it for this week's sessions. Next week, we will be going into setting up some shooting and raycasting, in addition to some other things. So thank you so much, guys. Have a great weekend, and we'll see you in the next session.